So here comes the second half of Unit 6, Part 1. So in the first half, we learned how to combine polynomials, how to add, subtract, and multiply. Today, we're going to learn how to undo polynomials. Now, many times we think of division as kind of breaking things apart, but with polynomials, it just gets kind of different. So I know that that's the last of our operations that we need to do, but with polynomials, division is a whole different ballgame. So instead of thinking of this as division, we're going to think of this as factoring. When we undo multiplication, we think of, okay, what things multiplied together to give us our answer, right? If you think back to radicals, when we broke radicals into their factors, we're going to be doing the same thing here with polynomials in the second half of Unit 6, Part 1. So today we're going to start with the basics. We're going to learn the most common way of factoring, which is called the GCF, or greatest common factor. And then we're going to show what answers will start to look like when we're factoring polynomials instead of combining them. So as a warm-up, we're just have three different sets of numbers here, and I just want you to think about what's the biggest number or term that you could divide all of these listed numbers by, and when we say that, we mean that they would divide evenly, right? Like, what would be the biggest factor that would go into each of those numbers in this set? Go ahead and pause your video and try it out. So if I look at number 1, my numbers are 20, 30, and 40. So I know that each of those has a factor of 10, right? Maybe you said that each of them has a factor of 2. That's true. Maybe they each have a factor of 5. Yep. But we want the biggest number, right? The biggest number that you could divide all of these terms listed by. So the first one would be 10. All right, now in number 2, when we're looking at these, I see that the biggest number that I could divide all of these by would be 5. But I notice that they all have an x in common. I could divide all of them by x and it would work out great, right? X would be a factor in each of those terms. So my biggest term that I can divide all of them by would be 5x. So just kind of getting that idea that in this unit we could have not only numbers as factors, but variables as well. All right, looking down at the bottom, ooh, we wanted to say 5, right? But that 23 kind of threw it off. Oh man, I don't know. What does go into 23? Nothing. So I don't think there are any numbers that would have a common factor between all of them, but I do notice that they all have an x. And so in this case, the biggest term that I could divide all of them by would be x. Now what we just practiced there is we practiced finding the greatest common factor, right? The biggest factor that is a factor of all of those terms, right? That's what we're going to practice doing, but now we're going to do it with polynomials. So instead of just having a list, well, here I have my polynomial. I have 8xy plus 12xw. So now I have this polynomial with 2 terms, but I'm going to do the same kind of process. I'm going to look at each of those just like I looked at my list in my warm-up, and I'm going to say, okay, what would be a common factor of the numbers, and do they have any common variables that would be part of our greatest common factor? So if I look at 8 and 12, I notice, okay, they definitely have a common factor of 2, but that wouldn't be the greatest common factor. They also have a common factor of 4. And then I notice they both have an x, just like in our warm-up, where we had some of them that had x's in common as well. So our greatest common factor for this one would be 4x. They both have a 4 as a factor of the numbers, and they both have an x as a factor as well. Okay, now, we're not done when we find that greatest common factor in this case. We're going to actually do this process of what would 4x have to multiply by in order to give me that polynomial of 8xy plus 12xw. So this is what we're starting on our journey of actually factoring. So we're going to break it into the things that would multiply together to give me my original polynomial. So if we think about this, we say, okay, what would I have to multiply 4x by to give me 8xy? Well, I'd have to multiply 4 times 2 and I'd have to multiply by a y to get that to be part of my answer, right? So my first term in my parentheses would be 2y. Then I have my plus sign that separates my terms, and then I see that I have my second term here, and I say, okay, what would I have to multiply 4x by to give me 12xw? Well, I'd have to multiply 4 times 3, and I'd have to multiply by a w to get w in my answer. So if I have 4x as my greatest common factor, I would have to multiply 4x times 2y to get 8xy, multiply 4x times 3w to give me 12xw. You can check your answer by thinking of it as distributing, right? And see if you get your original polynomial. And if you do, then you did it correctly. Remember again that you want to make sure that you take out the greatest common factor, right? Not just any common factors, but the greatest. If you don't get the biggest number out front, when you look at your terms that are left in your parentheses, they would still have something in common, and we would have to continue going on and take out more as a GCF. If you think back to radicals, right, we always were looking for the biggest perfect square factor to simplify our radicals. If we didn't get the biggest one the first time, we had to keep going and pull more out to the front. Same idea here with polynomials, okay? So just double check your parentheses and see, do they have anything in common? And if they do, then you need to keep working on those parentheses. But they don't in this case, so we are completely finished, and that will be our answer. Our answer will look like this. It's kind of like the opposite of what we were just doing before the quiz, right? Our answer is going to look like two things that are multiplied together because we're undoing that multiplication and putting it into factors. All right, let's look at number 2. I have 6x to the 4th minus 15x to the 3rd plus 3x squared. So I look at my numbers first. I say, okay, what would be a common factor? 6, 15, and 3. Well, they all have a factor of 3, right? I don't think I can get anything bigger than that with my 3x squared at the end. I think 3 is as big as it could go. All right, so I definitely have a 3 as part of my GCF. And I see that they all have an x, but be careful here. How many x's do they have in common? My first term has 4 x's. My second term is 3 x's. My third term is 2 x's, right? X to the second is 2 x's. So they all have at least 2 x's. And so I'm going to take x squared out as my greatest common factor, right? They all have at least 2, so I could take 2 out to the front. I can't take 3 out to the front because then that last term, how am I going to take 3 x's away when there's only 2 to start with, right? So just think of how many do they all have. If they have more than that, okay, but what's the least number that they have, and that's what you can bring out as your GCF, okay? So then I'm going to say, all right, what would I have to multiply this GCF by, this 3x squared? What would I have to multiply it by to get back to my original polynomial? So what would I have to multiply 3x squared times to get 6x to the 4th? I have to multiply by 2x squared, right? 3 times 2 is 6. I had 2x squareds out, or 2 x's out front. I needed 2 more to get to x to the 4th. So x squared times x squared gives me x to the 4th. All right, now my middle term here, 3x squared times what gives me negative 15x to the 3rd. That'd be negative 5x, right? Or x to the 1st if you want to. I have to have 1 more x to get to x to the 3rd. I already had x squared out front. I need 1 more to get to x to the 3rd. You don't have to write x to the 1st. You could just write x if you want to. And my last term here, 3x squared times what gives me 3x squared. Now be careful. 3x squared times 1 will give me 3x squared. So just remember, I can't just leave this off, right? Because if I just left it blank, oh, it's already a 3x squared. If I just leave it blank, if I went to check my answer and I distributed, and I didn't have that plus 1, I would only have 2 terms. But I'm supposed to have 3 terms, right? So you have to have that 1. Remember, 3x squared times 1 gives you 3x squared, so just be careful. Big thing to remember is however many terms you start with in your original problem is how many terms you should have in your parentheses when you factor by GCF. So I started with 3 terms, so I should have 3 terms in my parentheses. All right, let's look at another one. So just remembering those variables, you're looking for how many could I take out, right? What do they all have? Okay, so if I look 4m to the third n minus 7m squared n squared. Well, if I look at my numbers first, I have 4 and 7. They don't have any common factors. So what I have to look at is the variables. I have m to the third and I have m squared. So there's 3 m's in the first one and 2 m's in the second. So they both have at least 2. So I can take m to the second out, right, as my GCF. Then I notice that they have n in the first term and n squared in the second. So they have 1 n in the first term and 2 in the second. So they both have at least 1. So I can take out an n as well. So my GCF for this one is going to be m squared n. And that's okay. You can write a 1 out front, but you really don't need to. A factor of 1 doesn't really do anything. So I'm just going to write the variables out there. Okay, so now, what would I have to multiply 4m squared n by to give me, what would I have to multiply m squared n by to get 4m to the third n? Well, I definitely have to multiply by 4. I see I have m squared as my GCF. I need to get to m to the third, so I need to have 1 more m. But I don't need any more n's because I already have n in my GCF out front. So just think about it, multiply, like distribute really quick. M squared n times 4m would give me 4m to the third n. Okay, how about my second term then? What would I have to multiply m squared n by to get negative m squared n squared? Definitely have to multiply by negative 7. I see I already have my m squared, and I have 1 n, but I need to multiply by another n to get it to be n squared. Do a quick distribute in your head. M squared n times negative 7n, negative 7m squared. Now I have 2n, so n to the second. There is our final answer. When you have more variables, it does get a little bit more complicated, but just, do a quick double check in your head. Do you have as many as you need? Remember, those exponents are telling you how many of that letter you have, and make sure that you add them up to the right number. All right, number 4, negative 6x to the fourth y to the third minus 12x squared y to the fifth. When I look at the numbers, be careful, this one's a little bit tricky. So here I look at the numbers, I have negative 6 and negative 12. So the common factor that they have is actually negative 6. Now we've had negatives show up before, but if you notice in this one, all or both, but really all of the terms are negative, right? So the only time that you have to take it out as a negative number is if all the terms are negative. So you only have to take, I should say factor. That would make more sense. Sorry. You only have to factor out a negative. Whoops. If all the terms are negative. Now, other than that, it is optional. There are certain occasions when we would prefer that you take out a negative, which we'll get to a little bit later on. But if they all are negative, if every single term is negative, then we have to take it out as a GCF. Okay, so be careful about that. All right, so negative 6 definitely, but now let's look at our variables. I have 4 x's in the first term, 2 x's in the second, so I can take 2 x's out. They both have at least 2. I have 3 y's in the first, 5 y's in the second, so I can take a y to the third out. They have at least 3. All right, and then I am going to write down what would I have to multiply by to get back to my original, right? So what would I have to multiply negative 6x squared y to the third by to get negative 6x to the fourth y to the third. All right, well, I already have the negative 6. I need 2 more x's, so I'd have x to the second that I'd have to multiply by to get to x to the fourth. But I already have the y to the third. All I have to multiply by is x squared to get up to that negative 6x to the fourth y to the third. How about my second term? Okay, what would I have to multiply negative 6x squared y to the third to get negative 12x squared y to the fifth? Negative 6 times positive 2 gets me to negative 12, right? Negative 6 times positive 2 gives me negative 12. Watch those negatives. I wouldn't have a negative in that part. All right, I already have 2 x's. X squared goes to x squared. Don't need to multiply by any more x's. Y to the third, I need to get to y to the fifth, so I'd have to multiply by y squared. I need 2 more. So our final answer there is negative 6x to the third, y to the third. And just remember, you have to factor out a negative if all the terms are negative. If all the terms are not negative, then it is optional to factor out that negative. All right, just the last couple here, just to make sure that you are feeling really confident about factoring by GCF. The more you can do here on your own, the better you will be. Let's take a look at number 5. If I'm looking at my numbers, 3, negative 12, and 18, I'm seeing that the biggest number that they have in common, the biggest factor would be a 3, right? I can't go bigger than that. I was thinking 6, but that first term kind of throws that off. And then I have m to the fourth, m, and m to the second. So I have only one m in that middle term, so I can only take one out front. I see that they all have an n as well, n squared, n to the third, n squared. So I can take out an n squared with my 3m. There is my greatest common factor. Notice in this one, there was a negative in there, but they weren't all negative, so I'm not going to take out the negative as my GCF. Okay, 3mn squared times what? Gives me 3m to the fourth n squared. I already have the 3, I already have the n squared. I need 3 more m's, so m to the third times the 1m that's already out front would give me to m to the fourth. All right, middle term, 3 times negative 4 would give me to negative 12. I'm already there on my m's. N squared to n to the third, I need 1 more n to multiply by. Last term, 3 times positive 6 would give me to positive 18. I have m out front. I need to get to m squared, so I need 1 more m. But I have n squared out front. I already have an n squared, so I don't need any more n's. So my last term will just be 6m. Got it. Okay, last and final one here. What do we have in common? 15, 10, and negative 20 looks like we have a 5 in common here. I see they all have a y, y to the fourth, y to the third, y to the third, so I can take out a y to the third. They all have a z in common, z squared, z to the third. Looks like the biggest one I can take out is just 1, z. Okay. What do I have to multiply 5y to the third z by to get 15y to the fourth z? 5 times 3 gives me 15. I have y to the third. I need to get to y to the fourth, so I need 1 more y. I already got my z, so I don't need any more z's. Middle term, 5 times positive 2 gives me positive 10. I already have my y to the third. I have z, but I need to get to z squared, so I need 1 more z on that term. Last term here, 5 times negative 4 gives me negative 20. I have y to the third, that was all I needed. I have z, I need to get to z to the third, so I need z squared to get there. All right, hopefully, I know I went through those last two kind of quickly, but hopefully you're getting the pattern and getting the idea. Remember, if you don't get everything out front in the first time, when you look at your parentheses, you should see that they still have something in common, and you need to take more out. Either go back and try again, or go on to the next step, take more out front with it, and just take those little bits off. You know, either way, just keep going if you see anything in your parentheses still has things in common. All right, just to wrap it up, greatest common factor is the greatest term that goes into every term of the polynomial evenly, right? And write your final answer in factored form. So make sure you write that GCF out in front, you write your parentheses, and what would you have to multiply that GCF by to get back to your original? That's what goes inside the parentheses. That's what our answers are going to look like now when we are factoring.